Hello everyone. In this lesson, I'll solve the exercises of lesson 2.5 with the ministerial questions of this lesson. Question number 1 to 4. Find limits of f of x as x approach to negative 2 from left and from right. Number 1. Use this graph to find the limit when x approach to 2 from left and from right. As you see, when x approach to negative 2 from left, f of x goes to positive infinity. It is increasing without bound. And when x approach to negative 2 from right, also the function goes to positive infinity. It is increasing without bound. So when x approach to negative 2 from left or from right, for of x equal to positive infinity. Question number 2. When x approach to negative 2 from left, f of x goes to negative infinity. It is decreasing without bound. And when x approach to negative 2 from right, as you see here, the function goes to positive infinity. It is increasing without bound. Question number 3. Use this graph to find the limit. When x approach to negative 2 from right, the function goes to negative infinity, and when x approach to negative 2 from left, the function goes to positive infinity. Question number 4, or graph number 4. When x approach to negative 2 from left, the function goes to negative infinity, and when x approach to negative 2 from right, the function goes to positive infinity. Question number 5 to 13. Find the vertical asymptotes for the following function if it is exists. F of x equal 1 over x power 2. If we want to find the limit when x approach to 0 for this function, this limit is not exist, or this function it is not defined when x equal 0, and 0 not make the numerator 0, therefore x equals 0 is vertical asymptote for this function. Number 6, set x power 2 minus 9 equals 0. Analyze difference of 2 square to find the value of x minus 3, x plus 3 equal 0. Then x equal negative positive 3. Here are the vertical asymptotes for this function since x equal negative positive 3, not make the numerator 0. Question number 7. Set x power 2 minus x minus 2 equals 0. By experiment, x minus 2, x plus 1 equal 0. Then x equal either x equal 2 or x equal negative 1 are the vertical asymptotes for this function since this value not make the numerator 0. Number 8, x power 2 minus 4 equals 0. That's mean x equal negative positive 2. Negative positive 2 are the vertical asymptote for this function. Number 9, since the domain of this function is R, then there is no vertical asymptote. And if I set x power 2 plus 1 equals 0 and try to solve it to find the value of x, then x power 2 equal negative 1 and x equal negative positive square root negative 1, not a real number. Therefore, this function has no vertical asymptote. F of x equal 1 over cosine pi x, set cosine pi x equals 0. That is mean pi x equal to pi over 2 plus k pi or plus k n pi as you like. K is an integer number. factorize by pi for the right side. Pi 1/2 plus k, reduce pi with pi, then x equal to 1/2 plus k. K is integer. These are the vertical asymptotes for this function. Number 11, 1 minus 1 over x squared. Rewrite it as x squared minus 1, common denominator. Set x power 2 equals 0, then x equals 0 is a vertical asymptote for this function, since 0, x equals 0, not make the numerator 0. Number 12, analyze the numerator summation of 2 cubed x plus 1, x power 2 minus reverse sign, the first term times second term, plus second term square over x plus 1. Reduce x plus 1 with x plus 1, then I'll get the quadratic or the polynomial of degree 2. It has no vertical asymptote. Therefore, this function has no vertical asymptote. Number 13, tan x over x. Rewrite it as sine x over x cosine x, either x equals 0 or cosine x equals 0. X equals 0 is not vertical asymptote, since sine 0 is 0. It is make the numerator 0. Then I'll check the second case, cosine x equals 0, then x equals pi over 2 plus k pi. These are the vertical asymptotes for this function. Question number 23. Give two functions f and g such that limit for f of x when x approaches to c equal positive infinity, and limit g of x when x approaches to c also equal positive infinity, but the limit of the difference of these two functions not equal to 0. If we set f of x equal 1 over x squared, then limit when x approach to 0 for this function is positive infinity, since it is x squared. It is not negative infinity. From left and right, the function goes to positive infinity. And if we set g of x equal to 1 over x power 2 plus 1 or minus 1, as you like, then the limit 1 over x squared plus 1 when x approaches to 0 is also positive infinity, since I can rewrite it as 1 over x squared, and the limit, as you see, when x approaches to 0 is positive infinity. But f minus g equal 1 over x power 2 minus 1 over x power 2 minus 1. 1 over x power 2 minus x power 2, then the limit when x approaches to 0 to negative 1 equal negative 1, not equal to 0. The ministerial questions of infinity limits. Question number 2. The limit of 4x or 2 over 2 minus x when x approaches to 2 from left is negative infinity, positive infinity, 0 or 2. 2 from left, then substitute every x with 1.5, number less than 2, over 2 minus 1.5 equal to positive value over positive value. It is positive infinity. Choice B. Number 4, limit x approach to 3 from right for x over x minus 3 from right. Substitute every x with 3.5. 3.5 minus 3 equal to positive over positive, then the answer is positive infinity. Number 5, x approach to 1 from left for 2 over 1 minus x. 1 from left, it is a number less than 1. 2 over 1 minus 0.5, 1 half. Then positive value over positive value equal to positive infinity. Choice D. Question number 8. 1 from left, substitute every x with 1 half. 3 times 1 half over 1 minus 0.5 equal to positive value over positive value equal to positive infinity. Choice B. Question number 9. X approach to 2 from right. Approach to 2 from right. Then substitute every x with 2.5. 2 minus 2.5 equal positive value over negative 2 minus 2.5 equal to negative infinity. Choice A. Which of the following limits is false? Let us check the first one. 2 from left. Take the number less than 2. 1 over 1.5 square minus 4 equal to 1.5 square. It is 3 over 2 equal to 9 over 4 minus 4. It is negative value. Positive, this equal negative infinity. This choice is false. So this is the right choice. Let us check the second one. X approach to 2 from left, then substitute every x with 1.5. 2 minus 1.5 equal positive over positive. It is positive infinity. It is not false. This limit, x approach to 2 from left, since I have absolute value here, then positive over positive, it is positive. It is true, not false. It is wrong choice. Let us check the last one. X approach to 2 from right. Substitute x with 2.5. 2 minus 2.5 equal positive over negative equal to positive infinity. Also, this is not right choice. The right choice is A. This statement is false. Number 13. X approach to negative 4 from left. Negative 4 from left. It is negative 4.5. Substitute every x with negative 4.5. Negative 4.5 plus 4 equal to negative value over negative value equal to positive infinity. Choice B. Number 14. If f of x equal negative 2 over x minus 1 square, then limit x approach to 1 from left is, since I have a square here, then the denominator is always positive. Negative over positive is negative. Then the right choice is A. The ministerial question of vertical asymptote. Question number 1. Find the equation of vertical asymptote of this function. The vertical asymptote, since I cannot simplify this function, I set 1 minus x equals 0, then x equal 1, Since 1 not make the numerator 0, then it is the right choice is A. Number 2, find the equation of the vertical asymptote of this function. Also, I cannot simplify this function. I'll set x plus 1 over x minus 1 over x plus 1. Difference of 2 square. Reduce x plus 1 with x plus 1. The function will be 1 over x minus 1. Then x minus 1 equals 0. The vertical asymptote is x equal 1, since 1 not make the numerator 0. The right choice is also A. Question number 4, find the equation of the vertical asymptote of this function. This function, I'll set 1 minus x equal 0, then x equal to 1, 1 not make the numerator 0, then x equal 1 is the vertical asymptote, and the right choice is C. Number 7, find the equation of the vertical asymptote of this function. Set x power 2 equals 0, x equals 0, 0 not make the numerator 0, 0. The right choice is A. Question number 8, analyze the numerator, the difference of 2 cube, x power 2 plus x plus 1 over x minus 1, reduce x minus 1 with x minus 1, we will get x power 2 plus x plus 1. This function is a polynomial of degree 2, has no vertical asymptote. Choice D. Number 9, find the equation of the vertical asymptote of this function. Set 5x over, factorized by x, x minus 5, reduce x with x, the answer is 5 over x minus 5. Then x minus 5 equals 0. This gives me x equal 5 is the only vertical asymptote of this function. Number 10, find the vertical asymptote of this function. Set 3x plus 6 equals 0. Solve to find x. X equal negative 6 over 3 equal to negative 2. Choice D. Question number 12. 1 minus 1 over x power 2. Set it x power 2 minus 1 over x power 2. Then set x power 2 equals 0. This gives me x equals 0. 0 not make the numerator 0. Then the right choice is C. The only vertical asymptote of this function is x equals 0. Question number 13. Analyze the numerator by experiment. X negative, then positive negative, 3 1 over x minus 1 square. Reduce x minus 1 with square. Still we have x plus 3 over x minus 1. X equal 1 is the vertical asymptote of this function. Question number 15, find the equation of the vertical asymptote of this function. F of x equal 1 over sine pi x. Sine pi x equals 0, then pi x should be equal to n pi, pi with pi, then x equal n is the right choice. Number 8. Find the value of a so that the function has a vertical asymptote at x equal 2. Since the function has vertical asymptote at x equal 2, then 2 should make the denominator 0. Then I substitute every x with 2 and set it equal 0. 2 power 2 minus 4 times 2 plus a equals 0. 2 power 2, 4. 4 minus, times 2, 8 plus a equals 0. Then a equal 4 minus 8 minus 4, take it to the other side, a equal 4. The right choice is A, which has a vertical asymptote as x equal 2, x equal negative 1, and vanishes for x equal negative 5. The rule is a function is vanishes over vertical asymptote equal to x equal negative 5, the bracket is x plus 5, over x equal 2, the bracket x is x minus 2, x equal negative 1, the bracket is x plus 1. Then the right choice is, let me multiply this two bracket, x power 2 minus 2x plus x minus x minus 2. The right choice is B. I'll get back to 28. Let me solve 23, which has vertical asymptote at x equal 2, x equal negative 1, vanishes for x equal 3. F of x equal 2 vanishes x equal 3. It means x minus 3 in the numerator. In the denominator, x equal 2, x minus 2 times x equal negative 1, x plus 1. Which choice is true? This one. Choice B. Question number 26. Which function has a vertical asymptote at x equals 0, x equal negative 2, and vanishes for x equal negative 4? It means x plus 4 in the numerator and x times x plus 2 in the denominator. The function is x power 2 plus 2x. It is this function, since I can rewrite this function as 3x plus 4 over 2x x plus 2. Therefore, this function has a vanish when x equal negative 4 and the vertical asymptote at x equal 0, x equal plus 2. This constant, it doesn't affect by the vertical asymptote and the vanish. Question number 27. The vertical asymptote of which function of the following are x equal 1 plus 2n? I solved this function here already. It is not 1 plus 2n, it is x equal n. Let me check this function. Cosine pi x equals 0, then pi x equal to pi over 2 plus n pi. Then pi x equal, factorized by pi, 1/2 plus n, pi with pi, x, the vertical asymptote is 1/2 plus n is not 1 plus 2, and it is wrong choice. Let me check this function, rewrite it as sine pi x over 2 over cosine pi x over 2, set cosine pi x over 2 equals 0, then pi x over 2 equals pi over 2 plus n pi. Pi x over 2 equal factorized by pi 1/2 plus n. Reduce pi with pi, multiply both sides by 2, then x equal 1 over 4, sorry, 2 times 1/2, 1 plus 2n. It is the right choice. Choice B. Question number 28. The vertical asymptote of this function is m pi or pi times n plus 1/2 or 2 times 2 plus pi or pi times n minus 2. This function, we can write it 1 over sine over cosine, then it will be cosine x over sine x. Sine x equals 0, then x equal n pi. Choice A. True or false? Number 1. Which is true? If f is undefined at x equals c, then the limit does not exist. This is wrong. It is not necessary the function to be undefined, then it has no limit. Many functions are undefined for the point and has a limit, like for example this function f of x is x power 2 minus 1 over x minus 3. This function is not defined at 3, but it has limit, since x minus 3, x plus 3 over x minus 3 equal x plus 3, and the limit when x approaches 3 is 6. If f of c equal L, then the limit of f of x when x approaches to c equal L. It is not necessary. Sometimes the limit not equal to the value of the function. For example, if we have piecewise function and x plus 1 when x not equal to 2, 5 when x equal to 2. Then the limit of this function when x approach to 2 is 3, but the value of the function is 5. So this is also wrong. Limit absolute value x over x equal 1 when x approach to 0. This limit is wrong. It is -1 when x approach to 0 from left and 1 when x approach to 0 from right. If f of x equals g of x for all x except 0, and limit f of x when x approach to 0 is L, then limit g of x when x approach to 0 is also L true. The two function matches all the at all the points except one point. Number 2, which is true? If limit f of x equal L when x approach to c and equal L and f of c equal, then f is continuous at c. This statement is true. If the value of the function when x approach to c is L and the limit also is L, then the function is continuous. The statement matches the condition of continuity. If f is a rational function, then it has at least one vertical asymptote. Wrong, since x over x power 2 plus 1 is a rational function and has no vertical asymptote because its domain is R. If function f has vertical asymptote at x equals 0, then f is not defined at this point. Also wrong, since if we have a piecewise function 1 over x not equal to 0, 2 when x equal to 0, this function has vertical asymptote at x and defined at 0. Has a vertical asymptote at 0 and also defined at 0. Number D, sine limit sine x over x when x approach to y1, wrong when x approach to 0, sine x over x is 1, not y. Number 3, which is true for this function. F is discontinuous and non-removable discontinuity at x equal negative 2. This function is discontinuous at negative 2 since negative 2 is not in the domain and the function is not defined at negative 2, therefore it is discontinuity, and the limit not exists, therefore the discontinuity is not removable since the limit when x approaches to negative 2 from right is is 1 and from left is negative 1, so this statement is true. F has a vertical asymptote at x equal negative 2. X equal negative 2 is not vertical asymptote since negative 2 make the numerator also 0, so this statement is wrong. F of negative 2 is defined, wrong. Negative 2 is not in the domain of this function since it makes the denominator 0. F is continuous, it is not continuous because negative 2 is not in the domain. The right choice is A, which is false. The domain of the function x over x power 2 plus 1 is R. This statement is true. The domain of this function is R, since x power 2 plus 1 is never, there is no value in real number make it 0. The slope of the line x equal 4 is undefined. Also, this statement is true since x equal 4 is vertical line and all vertical lines has undefined slope. Limit square root x when x approach to 0.25 it's 0.5. Also, this statement is true since the limit without limit, because square root 1 over 4 0.25 equal square root 1 over square root 4 0.5. If f of c equal L, then limit f of c when x approach f of x when x approach to c is also L. This statement is wrong. It is the right choice because it is not necessary for the function to be the value of the function equal to the limit of the function. Question number 5, which is false. If f is a rational function, then it has at least one vertical asymptote. This statement is false because it is not necessary for all rational number to have a vertical asymptote like x over x power 2 plus 1. This is a rational number and has no vertical asymptote. So the right choice is A. Let us check the others. A polynomial function has no vertical asymptote. It is true because its domain is R. The function f of x equal x minus 2 over x absolute value x minus 2 over x minus 2 is continuous and has no point of discontinuity. Wrong, because it is not continuous at 2, because 2 is not in the domain of this function. It makes the denominator 0. So this statement is also false. The right choice both A and C. Which is true? The domain of function square root x minus 5 is 0 to 5. If we set x minus 5 greater than or equal 0, then x greater than or equal 5, then the domain is 5 to positive infinity, and this function, this statement is wrong. The slope of the line 2x plus y equal 3 is 2. If we rewrite this line as y equal negative 2x plus 3, then the slope is negative 2, and this statement is also wrong. If limit f of x equal L, then f of c also equal L. It is not necessary. We solved it before. Limit x power 2 over x minus 4 when x approach to 2 is negative 2. Let us see. 2 power 2, 4 over 2 minus 4 equal 4 over negative 2 equal to negative 2. This statement is true. It is the right choice. Number 7, which is true for the function f of x equal x power 3 minus 27 over x minus 3. The domain of this function is R except negative 3. Wrong. R except 3. F is continuous at x equals 3. Wrong, because 3 is not in the domain of this function. F has vertical asymptote at x equals 3. Also wrong. If we analyze the numerator, the difference of 2 cubed, then it will be like this. Reduce x minus 3 with x minus 3, then the function has no vertical asymptote. The limit of f of x when x approach to 3 is 27 is true, since 3 power 2, 9 plus 9 plus 9 is 27. It is the right choice. Which is true of these four limits? Limit x minus 1 absolute value minus x plus 1 over x equal negative 2. Let us see. If we want to find this limit, we should rewrite this absolute values as x minus 1 when x greater than or equal 1, negative x plus 1 when x less than 1, and x plus 1 absolute value equal to x plus 1 when x greater than or equal negative 1, and negative x minus 1 when x less than negative 1. Now, if we write the number line to find the function here, when x greater than 1, the function, the absolute value is x minus 1. When x less than 1, the absolute value is negative x plus 1 for the first absolute value. For the second absolute value, when x greater than or equal negative 1, the function is x plus 1. When x less than negative 1, the function is minus x minus 1. Now, we want to find the value, the limit when x approach to 0. When x approach to 0, the limit will be, instead of absolute value x minus 1, I'll rewrite negative x plus 1 minus, instead of absolute value x plus 1, I read x plus 1 It will be negative x minus 1 over x. Negative x with plus x. It will be negative 2x over x. X with x, the answer is negative 2. This limit is right. Limit x approach to 3.6 for greatest integer number x minus 1 equal 3. The answer is 3.6 minus 1 greatest integer. For this value, it is 2.6, and the greatest is 2, not 3. It is wrong. Limit x approach to 2 for 2x power 2 minus 8 over 2 minus x is equal to 8. Let us see. Limit x approach to 2 factorized by negative 2. The function will be 4 minus x squared over 2 minus x. Difference of 2 square for the numerator, 2 minus x, 2 plus x over 2 minus x. Reduce 2 minus x with 2 minus x. 2 times plus 2, 4 times negative 2, negative 8. It is not 8, so C also is wrong. For D, find this limit. I'll solve it here. The rule of trigonometric function cosine x plus y equal to cosine x times cosine y minus sine x times sine y. Apply this rule for this term in the numerator, the first term. The limit will be limit delta x approach 0 for cosine pi cosine delta x minus sine pi sine delta x plus 1 over delta x equal to limit delta x approach 0. Cosine pi is negative 1. It will be negative cosine delta x. Sine pi is 0 plus 1 over delta x equal to limit delta x approach 0, 1 minus cosine delta x over delta x equal to 0. Also, this statement is true. Therefore, we have two statements true in this question. See you next lesson.